to Aryabhat Center for Theoretical Physics. This is another video on this lecture series Quantum World, and in this video I am going to talk about the nature of superposition. Quantum mechanics is the probabilistic description of the subtle nature or subtle world. And in this quantum mechanics we cannot precisely locate a particle and its velocity at the same time without disturbing the particle. So we cannot locate x or x dash position and velocity of this quantum system without disturbing the one of the properties. So this is the restriction of the quantum mechanics. Now we described any particle with the wave function. We described any particle with the wave function or state. So suppose a particle in state A. So we can write any state A as the linear combination of another state. So it can be alpha C plus beta D. Just like in vector calculus or in vector, we can write any vector as the linear combination of two vectors A and B, and state is the vector. So suppose and this alpha and beta is the complex number. Alpha and beta is the complex number. Suppose in the state C we have measured some property, we call it C or L, and in state D we have measured some property, we call it M. So we can say that the probability of finding a particle in state C is simply alpha square, and probability of finding a particle in D is simply beta square. So this is the nature of quantum mechanics, that probability of finding a particle is equal to the complex conjugate of this. It means it is not square alpha star or beta star. So this is the So this is the superposition principle, or you can say that probability of getting a result L in state C is equal to modulus square of the modulus of alpha, and probability of getting a result M or measurement M in this state D is the square of the modulus of beta, or alpha its complex conjugate, beta and its complex conjugate. So this is the principle of superposition, and this is the strange fact of quantum mechanics, that we can write state of any particle as the linear combination of another state, which in classical mechanics we cannot do, because in classical mechanics we can find precisely using the equation of motion all the movement of the classical system after some time. Now in in the next video we will continue this exploration of quantum mechanics.